Okay, so again, here's the situation. It's an optimization problem. So you have a fisherman on a rowboat and he wants to reach the store. He's 3 kilometers away from the shore, and the store is located 2 kilometers from the closest point to him on the shore. Okay, so he has, again, two choices. Either he rows straight here at 5 kilometers per hour and then runs at 13 kilometers an hour to the store. Okay, so he runs the maximum he could run, which is good, but of course he travels a big distance. Or he could row all the way to the store much slower, but a shorter distance, okay? Or a blend of both, so some way between both extremes, so some way down the shore. And we want to find where down the shore should he hit. Okay, so let's go. So we're already set up that we're going to call the point on the distance from the point where he hits the shore to the store. I'm going to call this x. And so this will be 2 minus x. And I could find what this distance is now using Pythagoras theorem. Okay, so now this I know that it's equal to 2 minus x squared plus 9 square root of that. Is that okay? Okay, so this is the first part of the trip. I'm going to call this part 1, and I'm going to call this the second part of the trip, which is when he runs. Okay, so the first part he rows, second part he runs. And so let's see what happens in part 1. Okay, so his velocity or speed is 5 kilometers per hour. And the distance that he travels is this expression here, so square root of 2 minus x squared plus 9. And so I could find the time. Okay, so how do you find the time?
Distance over speed.
Sorry, distance over time, or distance over velocity, right?
Yeah.
You all good with this? Who's not good with this? Okay, you all took physics in high school, I guess. You're in science, so you're making, maybe some of you are taking mechanics now. Okay, so the time will be the distance over the velocity, and that will be this expression 2 minus x squared plus 9 square roots over 5. So this is the t1, the time that it takes for him to get from his original point until shore, x away from the store. Is that okay? All right, second part, so velocity is now 13 kilometers per hour. The distance is now x, and so the time t2 is going to be, again, d over v. So that's going to be x over 13. Okay, any questions? Okay, so it's an optimization problem. So what do we want to minimize? So he wants to get there as quickly as possible. So we want to minimize the time, which is going to be basically t1 plus t2. Okay, so I don't hear any questions, so I keep going, right? Okay, so what is that? T1 is this. So square root of 2 minus x squared plus 9 over 5 plus t2, which is x over 13. And this is what I want to minimize with x between what and what? What are the possible values of x? What's the smallest value x could be?
0.
Very good. And the maximum?
3.
X could be 3.
Yeah.
So X is 3 means X is here, right? It's 2
2.
here. So,
2, yeah.
so 2, right? Between 0 and 2. So if X is 0, that would mean it's the case where he just rows straight to the store, right? X is 0. He doesn't hit the shore before the store. And if X is 2, he hits the shore 2 kilometers before the store, so straight down. That means he rows straight down and then runs. And at 0, he just rows to the store. So this is what I need to minimize on this interval. And this now is a problem that we could solve. We've done this a lot. Okay, so this is the harder part, is to set up our mathematical problem here, which is minimizing this function over this interval. Okay, so we're modelizing a problem. And that's why this part of the course is a bit more difficult. This and related rates, as you'll see, it's word problems, and you have to extract the mathematical information, the relevant information for your setup. Okay, so let's go.
Sir.
Yeah.
When we do the you find the extremes for x, like 0 and 2 in this case, do we need to do that if we're going to use the technique where you find the second derivative?
Yeah, still, yeah, because yeah, you should. Okay, technically, let me think. I think of a case, but you're better safe. You're safe. It doesn't cost much to plug in the 0 and plug in the 2 in the function, so might as well.
Okay.
Okay.
Thank you.
But it's a good question. Okay, so what do we do now? What do we do? Okay, guys, you're sleeping today. I don't see anyone. I don't hear anyone.
We find the derivative.
Okay, let's go. We find the derivative. So t prime. So you have to derive this. What is the derivative? So I'm guessing you're good at this by now. I could do it one shot. Okay. So this would be over 2. So 5 stays downstairs. This will be 2 times this big square root times the derivative of the inside, which is 2 times 2 minus x times -1. Plus, this is 1 over 13. Okay, so I went a bit fast with the derivative here. I did the chain rule, right? The power rule with the exponent, and then the chain rule with the derivative of the inside, which is right here on top. Okay, when you're going to do it slowly at home, you'll see that it's very easy. Okay, so I'm going to cross this out, 2's. And now I'm going to put t prime is equal to 0. Let's solve this. So this means that 2 minus x times -1 over 5 times the square root of 2 minus x squared plus 9 plus 1 over 13 is equal to 0. So if I send this on the other side, so I'm going to get 2 minus x over square root 5 times, square root of x of 2 minus x squared plus 9 equals 1 over 13. Okay, so basically I send this on the other side, so everything positive. And now I could cross multiply. So 13 times 2 minus x is equal to 5 times the square root of 2 minus x squared plus 9. Any questions? Okay, so how do I get rid of the square root? How do I get rid of the square root? I'm going to square both sides. Okay, so I'm going to put both sides squared. So right away, actually, I should have a restriction here because the square root could never be negative. So this cannot be negative. And so x has to be less than 2. But anyways, x is less than 2, so there's no problem. Okay, so you would have a restriction here. Okay, so anytime you have the square root of something equals to an expression with x's, you have to make sure that this is positive. Okay, and so this is positive if x is smaller than 2, which we already have. So no restriction necessary here. Okay, so let's square both sides now. So 169 times 2 minus x squared is equal to 25 times everything inside here. 2 minus x squared plus 9. Okay, so I could open everything up, or I could be a bit smarter because I recognize the 2 minus x squared in both cases, in both sides. So 169 2 minus x squared equals 25 2 minus x squared plus 25 times 9 is 225. Okay, send everything to the left. So I get 144 times 2 minus x squared equals 225. And divide by, so 2 minus x squared equals 225 over 144. Square root. Two minus x is equal to plus or minus the square root of this, so 15 over 12. And so x is equal to 2 plus or minus, so 15 over 12, if I divide by 3, I get 5 over 4. Which are two possible values. So 2 minus 1.25 is 0.75, or 2 plus 1.25 is 3.25. Okay, which of course we disregard because it's not in our interval. Okay, not good. So this seems to be our value. And I just need now to verify if it's a maximum or a minimum. I'm going to do it down here. So t of 0, t of 0.75, and then I'm going to do t of 2. Okay, you with me?
Yeah.
Okay, good. So that I'm just gonna make a box around t so that I can refer to it fast. Okay, so t of 0, so let's plug in 0 in here. So 0, 2, 2 squared is 4, 4 plus 9 is 13, so root 13 over 5. So I think I need a calculator for this. So square root of 13 divided by 5 plus, 0. Well, this is x is 0. So 0.72. So 0.72 hours it's going to take him. Okay, that's the case where x is 0. So if he just rolls straight to the store, it's going to take him 0.72 hours. Let's see at 2. Okay, so if x is 2, so that means he rows straight to the shore and runs. Okay, so if it's 2 here, what do I have? I get 0 plus 9 is 9, square root 3 over 5 plus 2 over 13. So 3 over 5 plus 2 over 13. I get 0.75 hours. Okay, so now let's see 0. So he's already better off rowing straight, okay, than running. Okay, let me see somewhere here if he's better or not. So let's put 0.75 here. So 2 minus 0.75, which is 1.25, squared plus 9 square root divided by 5 plus 0.75 divided by 13. There you go. I get 0.708 or something. Okay, so as you see, this is the minimum. Okay, any questions? Okay, the other way to do it, okay, like I think Faye said before, is I could find the second derivative here, and you will see that you will get definitely a positive value here. So it means that the function is open upwards, and so we definitely have a minimum, and that will work out as well. Any questions?
Sir,
Yep.
if you go back to the beginning of the problem, when we were looking for the T1 and the T2,
Yep.
for the T2, we took, like, could you explain again how you found these two things? Like why you decided to use these? I don't know how to explain them.
I don't know what you
Like basically, how did you figure?
Sorry, I didn't hear you. What? How did what? Sorry, I can't hear you. Okay, sorry, I didn't hear the question. I want to answer you, but I don't know what was the question.
Oh, sorry, my Wi-Fi is lagging.
Okay, perfect.
Can you hear me?
Yeah, I can hear you.
Okay. I just wanted to know if you could re-explain the way you found the two different T1s and T2s, like
Yeah.
how you knew which.
Okay, okay. You're lagging, but I think I understand what you want. Okay, so let me answer for you. So how did I, so in case you never did some physics, okay? So T2 is the time that is going to take him to run here on the shore, okay? So basically, he travels 13 kilometers in 1 hour. If he does X kilometers in how much time? Do you understand that? Okay, 13 kilometers in 1 hour, that's his velocity, speed. X kilometers in how many hours? Well, how do you find this? You do the diagonal divided by this one. So it's X kilometers times 1 hour divided by 13 kilometers. Okay, so cross out the kilometers, and so you're left with x over 13 hours. That's what I have here. That's the time. Do you understand or not?
Yeah.
Okay, that's it. And I did the same thing here. The only difference is that the distance here, the distance was x. Well, the distance here was this big expression because I had to do Pythagoras to get this. Same idea. Instead of having an x here, I will have this. And instead of having 13 kilometers an hour, I'll have 5. And I'll do the same process. Yeah?
Yeah.
Sure. If it's not clear, I'll repeat. You have to make sure.
No, I mean, I understand the physics behind it. I understand
Okay.
the speed, but the problem is that the top I understand, right? But the for the T2, why didn't we take like the total 2 kilometers?
Oh, because I don't know who says it's going to stop here. So why do you understand this one? How come you understand this one? Why didn't you take 3 also here? Or why didn't you take the Pythagoras 2, 5, 2, 3 and find this? Why?
Oh yeah, that's true.
Okay, it's somewhere in between. So it all depends on the x now. Okay,
Oh, okay, thank you.
good. Okay. All right, is that clear? Everybody? Okay, so if it's clear, I'm going to give you another one right away. Okay, so here's one. That's the last one. I think after this one, we could move on a bit, and you could do the ones that I posted. And if you have questions, I'll do them. Okay, but I think like we did 5 examples. I think it's enough. Is there another one? No, I think that's it. I just did 5. Okay. Okay. Okay, so what do we have here? We have a triangle, a right triangle, with a height of 4 and a hypotenuse of 5. So basically a side, another side, a base of 3. Okay, so basically that's what I have. So let me see. So what's given to me? The height is 4. The hypotenuse is 5. So obviously this side is 3. Okay. What are we looking for here? I'm looking for the biggest rectangle that I could inscribe inside. Okay, so basically I should go like this. This is my rectangle right here. Okay, so I want to maximize this area. Okay, I'm going to find the dimensions. Is the question clear? Is the problem clear?
Yes.
Okay, Anybody want me to re-explain? Okay. All right, so let's label some values here. So I guess I'm gonna call this X, and I'm gonna call this Y. Okay, so basically this is X, and this is 3 minus X. And then here this is Y, and this of course will be 4 minus Y. True? Okay, so let me write down. Right away, what do I want to maximize? We want to maximize the area, which is XY. That's what I want to maximize. That's pretty clear. That's easy. It's the area of the rectangle. Okay, so the only thing I need now is to be able to find a relation between X and Y so that I could express the area in terms of only one variable, either X or Y. Okay, so where am I going to find relations here? No? You don't see?
Joe,
Okay.
similar triangle.
What? Sorry?
There's two similar triangles.
Very nice. There's 3 of them, right? There's this one here, the small one up here, and the big one. Okay, all 3 are similar triangles because, as you see, angle, angle. Okay? So I could take, and all 2 small ones are similar to the big 3, 4, 5 triangle. So since I'm gonna label the corners so that I could name the triangles. I think it's better this way. So I'm gonna call this triangle A, B, C, and here I'm gonna call this point D, E, and F. Okay, so triangle EDB is similar to triangle CFE, which is similar to triangle ABC. Okay, because of the angle property of similar triangles. Good. So this means that the sides are proportional. In other words, if I do X over 3, it's the same thing as if I do 4 minus Y over 4. Good? X over 3 equals to 4 minus Y over 4. And that's it. That's going to be my relation. I'll be able to express everything here in terms of one variable now.
Sure.
Yep.
Could you repeat what you said, please?
Yep. Sure. So do you understand that the triangles are similar?
Yes.
Okay. So this is what you don't understand, this relation?
Yes.
Okay. So these triangles, look at this. I'm comparing this small triangle here. Okay. Which has a side here of X and a side here of 4 minus Y. I'm comparing it to the big triangle, which has a side here of 3 and a side here of 4. Okay? So the sides need to be proportional. So this side divided by the big side, so X over 3, has to be the same as this small one divided by the big one, 4 minus Y over 4.
Okay.
Okay, good. Anybody else? Okay. So let's isolate the Y here. So 4X is equal to 12 minus 3Y. And so 3Y is equal to 12 minus 4X. And so Y is 4 minus 4/3 X. Okay, so this I'm going to box. This one's important. And I'm going to replace it back here. And so therefore, the area of my rectangle is x times y, which is this, 4 minus 4/3 x. And that is equal to 4x minus 4/3 x2. This is the area. You with me? Okay, x, what's the interval? What's the smallest value of x?
0,
0, and the biggest?
3.
3.
Okay, so x is between 0 and 3. Okay, so hopefully if I plug in 0 here, I should get an area of 0. And if I plug in 3, I should get an area of 0 as well. You could check, it probably works. Okay, so now we're going to maximize. So let's find the derivative. So a prime is equal to 4 minus 8/3x. This is my area, my derivative. A prime equals to 0 implies that 4 minus 8/3x equals 0. And so if I solve for x, 12/8, so 3/2. So x is equal to 1.5. Okay, and if x is 1.5, you could find the y. I could plug in the y here, the x here to get the y. So 4 times 1.5 is 3, 3/3 is 1. No, 4 times 1.5 is 6, sorry. 6/3 is 2, 4 minus 2 is 2. Okay, so I find x is 1.5, y is 2. Let's verify if it's a maximum or not. So a of 0, a of 1.5, and sorry, I'm going to move up a bit. And a of 3. So a of 0 is 0, a of 3 is 0, you could check. And a of 1.5, I plug in 1.5 in here. Let's calculate. I get 3, which is normal. It's the area. 1.5 times 2 is 3. Okay, and so this is the maximum area. That's it. That's it for optimization. Is there any questions before I move on to the next section? Okay, no questions. I'm going to post these sheets. Okay, let's move on. So writing, are you good? Okay. Okay, so I have to show you now 3 more theorems. Okay, the intermediate value theorem, then Rolle's theorem, then the mean value theorem. Okay, 3 theorems. And after that, I think we're going to go to L'Hopital's rule and then curve sketching. No, related rates, L'Hopital's rule, curve sketching, and we're done the course. Okay. All right, so let's go. Intermediate value theorem. Okay, no questions? I can move on. Okay. So the intermediate value theorem. Okay, so let me first write it down formally, and then I'm going to explain what it means. Suppose, so let f be a continuous function on the closed interval, let's say AB. Okay, and let's say n be any number between f of A and f of B. Okay. With f of A not equal to f of B. I'm going to explain what that means in a second. Okay, so this is the hypothesis. So what could you conclude for this? Then there exists a number C in the interval AB such that f of C equals n. Two seconds. I'm just going to illustrate this theorem on the right. Okay, could I continue? You done? Okay. So I have a function here that's from A to B. Okay, so it goes from A, let's say, to B. I don't care how it goes. Okay, like this. And here I have f of A. And then up here I have f of B. That's my situation. That's what I start with. A function defined over a closed interval AB. So f of A works, f of B works. What does the theorem tell me? What does it tell me? It's that if I take any value, any number between f of A and f of B, so any number here, okay, then there for sure there is a number in AB, so inside the interval here, so a number C, for which f of C is equal to n. Here's my C. Do you understand what I just said? What the theorem tells you?
Yeah.
Okay, so again, it's a bit, I usually students find this a bit difficult because it's a bit twisted. Okay, but the idea is that if f is continuous on AB, it has to be continuous. If it's not continuous, then it's not necessary that you will find the C. Okay, but if it is continuous, any value in between f of A and f of B has a source in AB. That's what it means. Good. That's the intermediate value theorem. That's it. That's all there is to say. I'm not going to prove it because it's really not in the scope of this course. Okay. It requires more advanced notions that you don't have. Okay. Concepts. But just you have to understand how it works is that if f is continuous from A to B, for sure, every value between f of A and f of B has a source in the interval AB. Guaranteed. You cannot find a value here that there is no source that will reach it.
Does it get any harder than this, or is this all it is?
That's all it is, but I'm going to give you a problem now. And with the problem, you're going to say, oh, okay, I wasn't expecting this. So let me give you the problem. Okay, I'm going to take one from the book. Okay.
So sorry, so it means that between f of A and f of B, any y value has an x value associated with it. That's what it means?
Yeah, an x value associated that comes from the interval AB. Not the C has to be between AB.
Right, okay.
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 So the example show that four x cubed minus 6x2 plus 3x equals 2. So this equation here has, so we don't know how to solve this. I don't know how to solve this, okay? But show that it has a solution between 1 and 2. Okay, so I'm sure it looks weird because it seems to have nothing to do with this. Okay, so let me show you how to solve this. Okay, and how does it relate to this theorem? Okay, so I'm not asking you to solve this equation. I'm just asking you to prove to me that there is at least one answer, one solution to this that lies between 1 and 2. There might be more, but there's one between 1 and 2 for sure. Okay, so let's do this. So let f of x, so the function, I'm going to send everything to the left. 4x cubed minus 6x squared plus 3x minus 2. Okay. So this function is a polynomial, so it's definitely continuous. Okay, so f is a polynomial. So f is continuous. That's not a problem. So I need to verify that it's a function is continuous. Okay, so my function is continuous. Now let's see what, so we're looking for from 1 to 2. So let's see what f of 1 is. F of 1 is what? And then I'm going to find what f of 2 is. Okay, so f of 1 is, so if I plug in 1 here, I get 4 minus 6 minus 2 plus minus 2 minus 4 minus 1. I get minus 1. Okay, and if I plug in 2 here, I get 2, 8, 32, 32 minus 24 is 8, 8, 8 plus 6 minus 2, so plus 4 is 12. Okay, so what does this help me? Okay, let's just move up a bit. Let me see.
That means it's gonna go through the x-axis between
Exactly.
1 and 2.
Exactly. Okay, that's the idea. So that's what we use the intermediate value theorem here. Exactly. Okay, so my function is like this. Okay, so let's say at 1 and at 2. 1, 2. So at 1, it's worth minus 1, right? And at 2, it's worth 12. Okay, let's say it's here. Let's say 12 is here. Okay, 12. Okay, and my function is continuous. So you with me? So what does my theorem tells me? It tells me that every value between -1 and 12 has a source in 1, 2. Okay, so every n here, right, has a source. This is a theorem tells me, as you see, has a source here inside the interval. Okay, so since all of them have a source inside this interval, so 0 also has a source right here. You understand? Because 0 is also between -1 and 12. Good? You get it?
I'm sorry?
Yeah.
By source, you mean x, right? Just to
Yeah,
be sure.
exactly. Exactly.
Okay.
And the source between 1 and 2. Okay, so f of 1 is -1. F of 2 is 12. Every value, every number between -1 and 12, all of them. Okay, so -0.5, 0, 1, 6, 8, 11.9, all of them, they have a source in the interval 1, 2. So clearly, by the intermediate value theorem, 0 is between -1 and 12. So it has a source between 1 and 2. You get it?
So isn't this the case of all functions that are continuous?
All functions that are continuous on a closed interval, yes, it works. It's a big theorem.
So basically, it's kind of like the definition of the function, like of a function itself.
I don't know why you say that.
Isn't a function something continuous that has a y or x value depending, like let's say if you have an x value, it has a maximum of one y value.
Okay. So
Isn't this what the theorem is trying to say?
the
In a given interval?
no, the function has to be continuous. If the function is not continuous, that doesn't work anymore. If there's a jump, if there was a jump here, if the function was like this and there was a jump, then every value in that jump doesn't have anything in the interval. It doesn't work anymore. Do you understand?
Yes, so it has to be continuous.
It has to be continuous. And if it is continuous, all the intermediate values between -1 and 12 have a source between 1 and 2. That's what it says. Do you understand?
Yes.
Okay. It's a bit, it looks easy when I say it here, but when we do a problem, it's sort of, I don't know, there's like something that blocks. Okay. And even for me to explain it is a bit challenging. Okay. So again, so what I have to write a sentence here to prove. Okay. So since f of 1 is equal to -1 and f of 2 is equal to 12, then every number n in the interval -1, 12 has a source. I'm going to call this like this, a source C in the interval -1, sorry, not -1, sorry, +1, 2. You understand?
And can we see an example where it like it wouldn't have any source in between the interval, or would that just be if the function is not continuous or over a closed interval?
You mean a case where it's continuous over a closed interval and there is no source?
Yeah, if that exists, or just in general a
No.
case where we wouldn't be able to find.
No, it doesn't exist.
Okay. Okay.
It does, oh, you mean a case where you wouldn't find a zero, or I don't understand.
Like an example of a problem where we wouldn't be able to show that it has a solution in the interval. But in that case, it would just be if the function's not continuous or if the interval is not closed, right?
Or if maybe between 1 and 2, if the function was, instead of being -1 here, this was, let's say, 3. If f of 1 was 3 and f of 2 was 12, then nothing guarantees that it's going to touch 0.
Okay.
You could tell me, yes, between 3 and 12, yes, I agree. It's going to reach every value between 3 and 12, but it won't necessarily reach 0. It could, maybe when it went down and back up, I don't know, but it's not guaranteed. Here, I'm guaranteeing that it's going to cross the x-axis. Okay, so basically, forget mathematics. Just like if you're a kid, okay, and you're 5 years old, and I'm telling you, draw a line that connects point 1, -1 to point 212 without crossing the x line. You can't. You have to go like this. You have to cross the x line. If you don't want to cross the x line, you have to either jump or cheat, or I don't know. You understand?
Yeah, so it has to absolutely cross the x-axis in order for it to have a source. Okay.
Okay. It crosses every line y equals every line like this, y equals -1 until y equals 12. Every line it crosses. That's what it's saying.
Okay.
Okay, I'm trying my best to explain it, but it's the biggest challenge for a teacher is to explain it in simple terms. It's very difficult.
Sir,
Yeah.
so if f of 1 it would be like 3 or 4, then it wouldn't be
Exactly.
there wouldn't be any interim. But why?
What? Then what? What did you say?
But why?
They wouldn't. They would complete your sentence. If f of 1 was 3 and f of 2 was 12, then what?
Then why wouldn't it be an intermediate value?
It would be. The intermediate value theorem, it still works, but it doesn't guarantee that it's going to cross the x-axis.
Okay, so we're looking for it to guarantee that it crosses the x-axis.
Yeah, in this problem, because they're asking you when it showed that there is a solution to this equation. And you will see, okay, I'm gonna write now here. I'm gonna finish my conclusion, and then I'm gonna talk to you again, okay? So since f of 1 is -1 and f of 2 is 12, then every number n between -1 and 12 has a source c between 1 and 2 such that, okay, so basically f of c equals n, okay? That's what it means, okay? So, well, I'm saying it has a source, that's what it means, okay? So, namely, I'm gonna write like, then we'll use an English word that I don't understand. Namely, if n is 0, then since 0 is between -1 and 12, then for sure there is a c. Exists a c in 1, 2, such that f of c equals to 0. Do you understand?
Yes.
Okay, and this means f of c equals 0 means that this function here, 4c3 minus 6c2, this function here, sorry, plus 3c minus 2 equals 0. And therefore, there is a solution, 4c3 minus 6c2 plus 3c equals 2. There you go. So there is a solution. Yes, there exists a c that works. And that answers my question. Is that clear?
Oh, okay, okay. When I understand now.
Sir?
It's not easy. It's not easy. If you understand it right away, chances are you didn't understand it. It took me time to understand this. Tell me, yeah.
So like the reason why you chose like the number 0, it's because you sent everything to the, like you put the 2 on the side to make it 0.
Yeah, exactly.
Okay. So do you have to do that every time? You like always have to do that?
Pretty much, yeah. I mean, I could have done differently. I could have left it equal to 2 and labeled this the function and show that this, I'm going to try f of 1 equals something, f of 2 equals something, and I'll see that 2 is between the two things. You understand? That 2 is an intermediate value between whatever.
Okay.
Okay?
Yeah.
It's not that easy. Okay? It's a bit confusing.
So,
okay? Yeah.
Why did you make n equal to 0?
Because I want to know when is this function equal to 0. Because when this is 0, that means that this equation is satisfied. Understand? If I put this equal to 0, that ends up being the same equation. And that's what we want. When does this equation have a solution? Same thing as when does this function have a 0?
Do you think we could see another example just to maybe
Of course.
Thanks.
Of course. Let me see if I can find one. I'm going to try one in the book.
Sorry, can you re-explain why you put equal to 0?
Why, yeah, sure. Why did I put it equal to 0, the n equals to 0?
Yeah, like the last step, yeah.
Okay, so again, what I want, the question is what? Is show that this equation has a solution between 1 and 2, okay? So what I did, I put the 2 on the left, okay? And I wrote like this, instead of writing this equal to 2, I put this x on the left, the 2 on the left, and I put it equal to 0. Is that okay? That's the same thing?
Yeah.
Okay, so now my own thing I need to do is forget this. I'm going to consider this function, and I'm going to see when does this function ever have 0. Okay, so I'm going to check the value of this function at -1, sorry, at 1, and I found it's -1. Then the value of this function at 2, and I found it's 12. Okay, so that means that this function definitely crosses the x line between 1 and 2. That's this you're okay with?
Yeah.
Okay, so this means that this function definitely has a 0, because between -1 and 12, I find 0. 0 is an intermediate value between -1 and 12. Okay, and when this is 0, which I show that it is, it happens between 1 and 2. Well, if I send a 2 back there, then it shows me that this is the equation, it's satisfied. No?
Sorry.
1 second. Parsa, you had the question, right?
Yeah, I'm trying to like, is it, do we put equal to 0 to solve it, or like that's the part I don't get. Like I get it mathematically, but like I don't understand why we put 0 logically.
Why did I put the 0? This is 0 here?
Yeah, is it just to find like where it crosses the x-axis and that's about it?
No, not where it crosses, but I want to know that it's eventually going to cross it between 1 and 2. Okay, is it going to cross 0 between 1 and 2? Yes or no? Okay, instead of putting 0 here, okay, I could have put n equals 11. It's also going to work. Between 1 and 2, my function is going to be worth 11. Yes, for sure. And it's going to be worth -0.5 at one point also. And it's going to be worth 10 and 8 and 2. You understand? And 0 as well.
Yeah, I understand. Thank you.
Why did I single out 0? Because that's what brings me back to the equation that I want to show that it has a root between 1 and 2. You understand?
Yeah.
Okay, good. It has to be 100% clear, because even if it's clear now, I promise you're going to go after, you're going to look at the notes and say, what the heck did he say, this guy? Guaranteed, you're going to tell yourself this. Okay? Okay, sorry, I think Faye, you had a question?
Yeah, so like if we hadn't moved the 2 to the other side, would we have just replaced 1 and 2 into the like just the first 3?
This?
Yeah.
Yeah, very good.
We
Sorry,
would have
you can
done we would have done the same thing.
the same thing, and then this you would have put here f of c equals 2.
Okay.
Yeah?
Yeah.
Very good. Yeah, exactly. If you're asking me this question, chances are you understood.
Sir, can I also ask why in the solution, like for example, when you're writing, then every number n in the interval -1 and 12, the brackets, they're the open brackets and they're not closed.
Here?
Yeah.
Why is it open? Because look at my theorem. Then there exists a number between a and b not included.
Okay, and then when you also wrote that c is in the interval of 1 and 2, isn't that a closed interval? Because in the because in the theorem the interval AB is closed.
No, the c comes from AB open.
Okay, so whenever we talk about the c, it's always open.
Yep.
Okay, thanks.
Okay, question? Anybody else? Okay, we have, and class is almost over, but I could set you up with one last example if you want. Okay. Show that so ln x equals e to the negative x. So here's an ugly one. Has a root on interval 1, 2. Okay, so I guess I'm going to do it because we're running out of time. Okay, so maybe you could guide me through it. What would be the first step?
Is it sending everything to the left?
Very good. So I'm going to call f of x, I'm going to call it ln x minus e to the negative x. Okay, and it is continuous on 1, 2. There's no problem. Okay, the only problem would be if x was negative or 0. That would make ln of x have some trouble here. But since we're between 1 and 2, there's no issue here. Okay, so f is continuous over interval 1, 2, no problem here. Okay. So f of 1 is negative 1 over e, and f of 2 is ln 2 minus 1 over e2.
Sir,
Yep.
we need the graph to solve this, right?
No, you don't need to. I'm drawing the graph just to illustrate for you.
Okay.
Okay, that's how you prove it, the whole steps. Okay, and you mentioned that you use the IFET, right? Intermediate value theorem.